Cal, can you describe for us the process whereby, yeah, as you said, initially you thought, this will be easy, then you thought, no, this is going to be impossible. And then can you tell us how you were able to conceptualize that you could create an electrical field between those two opponents? And to the extent that I don't want to give away too much of the secret sauce, but like, how were you able to do that? And can you even just take us inside the creative process whereby, is it you at 2 a.m. at night with a big whiteboard in front of you, sort of drawing it all out? Or tell us about sort of the process of how you're able to breathe this to life, because it's amazing what you've done. Take us inside the workshop of how you did it, please.
Well, when I first started working on it, I was doing it as part of a final year project with the university.
Right.
And I had this idea of generating, just wasn't really thinking about it in terms of electric fields. I was just thinking generate a signal on, taking epee, for example, generating a signal on the guard of the epee, and trying to measure that signal with the tip of the other epee. And had some pretty good success with that. But the problem is, if you are taking that approach, is that fencers, they may start out dry and civilized, but after they've been fencing for 2 hours, they're wet, they're very sweaty. And
I bet.
if you put a signal on a guard, it can conduct through the sweat, and eventually your whole body ends up with that signal on it. So the system worked. This was the system, the original system that we designed, that I designed, I should say. It worked initially, but towards the end of it was useless. And when I tried to use it for foil or for saber, it just didn't work at all. And that was when kind of tried to reevaluate what was happening, drawing we had a whiteboard set up in the office, Tony and I, and we would draw pictures of what we thought was happening and then rub them out. And we had this rapid development cycle, so we were using a whole lot of modern electronics chips that you can really rapidly redesign the analog front ends. So they were called PSOCs, what we were originally developing on. We don't use them anymore, but they were very useful to have you don't have to redesign a PCB, you don't have to reassemble it and stuff. You can change the front end hardware relatively quickly, try something new. I was fencing every day. So I would go into the office, we would do a redesign. I would take this new design out to fencing and see when it would fail, what it looked like when it would fail, and just rinse and repeat. We went through a large number of prototypes, and there were a few brainwave moments. Oh, that's what's happening. Now I understand why this looks this way and this looks that way, and but eventually we ended up with something in our testing that we thought was pretty good. And the international governing body at that time, I think that was about 2014, they were looking for a company to design a wireless scoring system. And we thought, why don't we go? We'll talk to them. We'll see. We'll show them what we can do.
Yeah.
At that stage, I should say, we had a conductive T-shirt that we would wear. So underneath all of the other fencing equipment, there was a conductive T-shirt. You connect your system up to that.
I see.
Just basically means you've got this really good connection to the body of the fencer, which allows you to distinguish between the body and other things, right? If you don't have a good connection to the body, it's a lot harder to do.